Okay, in continuing the pressure washing testing series, I'm going to do something a little bit extra for this video. This is the AR Blue Clean 630 TSS HOT. So it's the hot water version. I want to talk specifically about hot water pressure washing and talk about specifications, and obviously we're going to do the testing like I've done to other pressure washers. And we're going to do it to this machine here, and I'm going to make this a standalone video. What we might throw in as a bonus is get the flow. So we'll do a flow test on my Kranzle K165 that's on the wall as well. But this machine here, it's all over the place online. The tricky part with buying this thing is most companies don't actually have it in stock. They just throw a price out there and then they have to wait for it, or maybe drop ship it, I guess. But I forget where I bought this from. I think it was Pressure Washer Direct. And I think it was about 700 bucks, 800. I think it retails for 800. I think maybe it was 750 I bought it for. So it's a couple $100 less than the Kranzle. The Kranzle is the K1322 TS, the one that I had brought over and made from Germany. There's a certain kind of fit and finish difference between the German engineered, German-made Kranzle, and I believe these are Italian-made. It's just not as nice. I mean, the pressure switch is not very, doesn't look very complete. The pump head isn't quite as clean. It's a lot like the Comet, where the fit and finish, it gets the job done. I mean, I guess it's a pressure washer, what does it matter? But there's just this is kind of like, it looks a lot to me like this is like a Corvette, and the Kranzle is a Porsche. It's just a different in refinement just from first glance. I actually used one of these a long time ago, but this was well before I was doing all this pressure washer testing. So it's been such a long time that I don't even remember what it sounds like or how it works. So we're gonna test it out here today. So the machine comes with a rather lengthy gun, just like the Kranzle. The quality of this is nowhere near the quality of the Kranzle gun, but it does come with this contraption here, which you'll probably never use. I've actually added a quick disconnect here to make it so that you can kind of remove and add the wand quickly if you wanted to make a change to it. And I've also added a plug here so that we could quickly disconnect. I think that the power cord looks to be about 50 feet, maybe 35 feet. I mean, we could always measure it, but pretty stout, heavy duty power cord. Looks to be, this is much different than the Chinese electrics. Clearly this is a different power cord, sourced from a different place than any of the other AR, low-end stuff. This is part of their professional line. And then they also ship it. It comes with a hose, a pretty typical hydraulic hybrid type pressure washer hose. Looks like a single wire. Doesn't really say what pressure or what type of hose it is, but pretty typical for a pressure washer. Not a terrible hose. Much better than any of the hoses that comes with any of the other stuff that the basic entry-level pressure washers come with. Much more pliable. So come to think of it, this isn't a hydraulic hose. This is definitely a pressure washer hose. It's even rated for temperature and 100 degrees Celsius. And it's clearly a single wire because it is pretty pliable. So not a terrible hose. Looks to be I don't think this is 50 feet. It's probably 35 feet because this is a 50-foot hose here. We can always measure it. So the difference here in the AR is that it comes with an M22 connection on one end and 3/8 on the other. So you can see I've put some quick disconnects so that we can easily connect up to the gun and wand like so. So we'll be sure to test out the operation here with the factory stuff, and then we'll swap out and do some modification. I've got a replacement hose, a Cobra Jet hose to replace. I've got an inlet hose to add to this equation, and then I've got a Mosmatic gun and wand to swap out and test with some different nozzles and a foam cannon to do the full battery of tests on this. But let's first, before we get into testing this, I'm going to talk about hot water. This is rated at 180 degrees. The Kranzle the K1322, the 1122, they're rated at 145 degrees Fahrenheit. And so I want to talk to you a little bit about and do a little bit of testing here at my house on hot water, because I know that's why a lot of people buy this, because they think they have to, because it has hot in the title. I don't think the hot part is necessary, because you're not going to get 180 degrees at your house. Maybe if you have a house built in the, I don't know, the early 1900s, and it still has an original boiler type water heater, but in general, modern water heaters aren't going to break, most of them aren't going to break 125 degrees. Maybe if you're lucky, even if it did 180 degrees, it's only going to do it in the tank. By the time it gets to your tap, it's not going to be anywhere near that. So I brought some testing equipment for this. This is all the testing equipment I use for all of this stuff, but I've got a MTM pressure gauge. So this is our reference gauge that we used for all of our testing. I've got a Fluke amperage meter, voltage amperage meter, clamp style. And then I made a little pigtail. So I have a pigtail here so we can grab the, the white wire and get our amperage rating. I've got an SPL meter, which we use for all the pressure washer testing. And then for this test, I have a Fluke, really expensive VT04. This is an infrared type temperature or thermometer. So we're going to use this to see what temperature water I'm able to get out of my tap, so that way we can give you an idea of whether or not the hot version of this even makes sense. I broke my little thing on this here, so I guess I'll fix that later. So I don't think that you need a hot version. Pretty much any pressure washer is going to be fine with hot, the hotness of, or how hot you're going to get out of the tap. Unless you had a separate boiler, like a company, I think they're out of Michigan or maybe Ohio, Hotsy, makes some boiler type. They actually have a boiler on a cart right next to the pump and the motor, and that's how you can get 180, 200 degree temp water. So we're going to go test that in the house here first, and then we'll come out here and run the battery of tests on the AR. So let's go check that out. Okay, so here's my water heater. So let's see, I think I have it set 130. Yeah, 130 degrees. So the max temp we can go on this is 140. So I have it running at 130. I think the recommended temp for most homes is 120. And then this has various modes, but heat pump mode would be the most efficient. I have it on boost because heat pump mode is doesn't get the water where it needs to get to. So my setup, I also have a recirculator. The recirculator runs all the way to the master bath, so that it makes the home a little less efficient. Makes this less efficient, but we combine the heat pump, helps offset the issue of running recirculated water through the house. So if the temp here is 130, the question is, what's the temp at a reasonable distance? So we'll walk into my kitchen and we'll run water and just get a temperature on our Fluke. So if a Kranzle or a Karcher or a Greenworks is rated at 140, 145, 150 degrees, then there wouldn't be any reason why you would need any special kind of pump, because you're not getting 180 degrees in pretty much any house. And even if you were getting 180 degrees here, the question is, this is 130, what is our temperature at the tap? So let's go check that out. All right, so here's my kitchen. This is like 40, I guess, what would you say, 55, 60 feet away. And it's probably, and the pipe is run underground and then through the foundation. So let's just get it up to temp. So it'll take a minute for, the recirculator doesn't feed this, it feeds the master bath, so we have instant hot water there, but not here. So it'll take a minute to heat up. Get a cup. In fairness, let's get a coffee cup so we don't lose heat instantly for all that coffee that I drink. So 130 degrees is enough to sting your hands. Yeah, she's a little right on the edge of hurting you. So 140 degrees will hurt your hands. I guess it depends on how tough your hands are. So there, we're at max temp. So that's showing the stream at 112 degrees roughly. Put in a cup here. .6, so 116 degrees. Oh, we got 120. So we're losing 10 degrees, assuming the water heater is somewhat accurate. Yeah, right at 120 and a half. 121 degrees right out of the tap. So imagine you're cycling this through your pressure washer hose, you're probably going to lose another couple of degrees. So there we go. I guess that would be a reasonable estimate, assuming your water heater is reasonably accurate. If it's 130 degrees at the water heater, I didn't know this, but it would just make sense that by the time the water gets to here, we're going to lose some temperature. And then I bet you if I held it in a coffee cup here for a minute or two, we'd start to drop a degree or so pretty quickly every 30 seconds to a minute. So imagine you're running that through your pressure washer line, so you're going to lose another couple of degrees. So I just think that the talking about having hot water pressure washers is not something that you need. It's not quite what it's cracked up to be. So what I'm getting at is any one of these electric pressure washers will be fine, even like if you're in Canada or you're in the Northeast or you're in in Montana or something, where you're going to want to wash with hot water. The hot water you're getting without a boiler isn't going to be enough to really affect any pressure washer. So I thought that was a little interesting test. So let's go out and do our other battery of tests on this machine and see what kind of flow, and we'll also see what we get from a pressure perspective. Okay, while we're here, let's just do some other testing here. I want to see how long this power cord is, and I want to see how long the pressure washer cord is, but I also want to see how much this thing weighs, because it weighs a gosh darn ton. So I got my fatness check scale. I'll just read it off to you. It's 56.5 pounds what this sucker weighs. So it's a good 10 pounds heavier than the Kranzle. I don't know if that's good or bad. Usually it's good. So let's measure the power cord really quickly so we have that spec for the video. Sorry about the fans, but it's like a bazillion degrees and humidity is insane. That's what I thought. It's 34 feet 6 inches. So let's say 35 feet. And I think the hose is going to be about the same. I think 35 feet's a good length for a power cord. Although you probably end up shelf mounting this thing, so you probably want it to be shorter. It looks like you could easily take this plastic cover off and you could get to the power cord here really easily and shorten it if you wanted to, I'm sure, without cutting it and doing some sort of janky soldering like I did to my my shelf mount Kranzle. But yeah, I'm guessing this is 35 feet as well. 35 feet I think is too short for a pressure washer hose. I think you're going to want it to be 50 or more. Yeah, it's 30 feet. Yeah, so 35 foot power cord, 30 foot. It's probably meters, so it's probably something slightly off, 30 feet, say 29 and change or something like that is our hose. But not a bad hose. I'm actually surprised. Pretty decent pliability, not bad. And I would want a longer hose likely. So, I think 50 foot's a better length. Especially, you can even notice, like if I had a pressure washer 10, 15 feet from my car, I'm gonna have to move this thing around. So I know a lot of you are gonna have your pressure washer unit sitting somewhere near your hose bib. So you're probably gonna want to upgrade the hose. You know, and the Cobra Jet hose is a better hose than this, even though this one isn't too bad. You know, it has decent termination, so yeah, not bad. Kind of like Kranzle, where, you know, the Kranzle, like the 1122, comes with a really nice 1/4 inch hose. This is a decent 3/8 inch hose. Okay, so now what we're gonna do, what I've added here, just for your information, so I've added a 3/8 inch coupler to a female coupler, and then this is an M22 female, which I just hand tightened, but apparently I tightened it. Apparently I tightened it a lot. I don't know how I did that. Just want to show you what this looks like. What the heck? Well, we're gonna leave this on. I just ruined this $5 fitting. You know, and that's part of Italian jankiness, if the threads were a little jacked up. But, you know, it can happen to any pressure washer. It could have happened in shipping or packing or something like that. So here's our soap inlet, which I'm assuming we can just pull the soap hose off and leave this alone, but we'll kind of play with that and see what happens. Here's our unloader valve knob, which we shouldn't really mess with. You should never mess with your unloader valve, just leave it open. And then we have, I put on a garden hose fitting here, and you know, the good news is that this one doesn't have some plastic crappy inlet section. It has a nice filter and has a solid garden hose type fitting on here. So this has an O-ring, so we really shouldn't even need to tape this. Let's just tighten it down just to be safe. Whenever you have an O-ring, like garden hose type, you don't want to go too tight because you'll mess it up. All right, so let me go put this in position. Man, I don't look forward to lifting this thing up. It's freaking 56 pounds. Yeah. All right, so let's get our machine connected. This is why quick disconnects are so nice. I have it plugged in. Let me show you how I have it set up here. So this machine is rated to draw 20 amps. So I'm interested to see what it pulls. I don't think it works on a 15 amp circuit at all. You know, where the Kranzle is technically designed to run on a 15, but usually when we're using the foam cannon, we need to step it up. So I've got this set up here where we're going to be able to pull and read amperage. I have all dedicated 20 amps. Not dedicated, but I think I have 3 20 amp circuits in here, so power's not going to be an issue out here in my wash bay. All right, so inlet hose. Take off my fancy bucket filler. This deserves to be put on the bench, not on the ground. Okay. Go in. Nice convenient spot. Notice how I'm a lot less cranky on when I start using the higher end stuff. Okay, now let's put our gauge in line. So we always want to put our gauge as close to the end as possible. I wonder if that'll be a problem that this is a little short. This hose is a little short in depth for what we need, so I hope this doesn't blow off in my face. Okay, so there's our gauge setup. OE. Let's give it some water, see if we got any leaks. Good to go. Okay, let's run some air through it. That isn't good. All right, let's crank it up. Uh-oh. There we go. So this is rated at 1900 PSI. We're getting a stable 1390. Probably 1380. So pretty typical. Let's see if this changes anything. It's a little unstable. Pressure switch works great. It's relatively quiet. It says 90 dB on there, but I don't think it's that loud. Not even close. Okay, give me, let's show them what are we getting from a current perspective. Yeah, 18. This is without a foam cannon. So we're drawing 18.3 amps. That's a lot of current. So you'd think we'd be able to, if it's drawing that much, you should be able to get more out of this thing, more pressure. Okay, let's do a flow test, see what we get. So if you haven't watched the other parts of the series, this is how I did my very unscientific way of run it for a minute and weigh it. Divide by, is it 8.32? 3, 2, 1, go. Feel like this sucker's moving some water. We're about to find out. Yeah, very pleasant, not loud at all, very, Kranzle-like. So that weight helps keep it, it's not vibrating around or anything, so that's nice. It's just, you can just tell, it's just considerably less quality. Get out of here. Considerably less quality than the Kranzle stuff. But it's less expensive, a couple $100 less. Oh yeah, that's a lot of water. Let's see. All right, so we're 17.5. It's fluctuating between 17.5 and 17.6. I got, so 17.6 minus 2.3 pounds for the bucket, 15.3 divided by 8.34, 1.83 gallons a minute. So about what I expect. That's almost identical to the Comet and the Kranzle. At 1300 psi. So we're going to pick up some flow here. So this might actually have more flow when we bring the pressure down. All right, so let's modify here. The hose won't make a difference. I would still upgrade the hose if I were you, but the hose doesn't make a difference in pressure or output. As long as you're under like 150 feet, it should operate identically. So I have a 4.0 nozzle on here. Let's see what happens. Yeah, we're gonna want to go 4.5. We're at 1200 p at 1210. So we're gonna go a little bigger. I need a 5.0. All right, well, we're gonna want a 5.0 nozzle. Let me have the 6.0 that's sitting on the bench there. Yeah, that 6.0 is giving me 800, like 790. So Chris just brought me a 5.0. We don't have a 5.5, figures we have every other size. Okay, good. 975 PSI, perfect. 5.0 nozzle it is. That's surprising. That means we really opened up the orifice here, which means we're gonna get a ton of water out of this thing, well over 2 gallons a minute, I bet. So let me grab my phone and let's test it. 3, 2, 1, go. Yeah, so we brought the amperage down now. It's gonna pull a lot of amperage when we do the foam cannon, but we're doing 14.4 with a 5.0 nozzle, so we're causing the machine to work a lot less. This is probably going to be 2 and change BPM. And that makes sense with the fact that this machine needs a 20 amp circuit. 21.7 minus 2.3 divided by 8.34. Yeah, 2.32 gallons a minute. Yikes, that's pretty legit. So 5.0 nozzle, 2.3 gallons a minute. Need a dedicated 20 amp, otherwise the sucker's going to be popping breakers like crazy. So let's test our dB, our sound, and then we'll test our what do we need to test? Foam cannon. Yeah, 70. So it is a little louder, 70 and a half dB, but that doesn't really matter all that much. So 70 and a half. Let's test our foam cannon. We're gonna make some soap, sticking with our same formula. So if we exceed 20 amps with a 1.25, we're gonna want to move up to a 1.5 nozzle on this, which of course I didn't bring. I think this will be fine. I mean, I use this on my 2.8 gallon a minute. So it'll work, it just might overamp the machine a little bit, and you can take that risk if you had one of these. I'm not foam cannoning any of my cars, so I don't care what you people say. I learned that lesson on this thing. Now I got water spots all over it. What do we got?
17.6.
Okay, good. So 1.25 millimeter. Obviously, we're getting plenty of foam. So, yeah, 17.6 amps. I think I might have to make a call to AR. What do you think? This thing's pretty legit. A little janky from a build quality perspective, but performance is good. Good foam. You need a 20 amp circuit though. I mean, we're at 17.8 amps. I mean, the Kranzle will touch 17.2 with a foam cannon with a 1.25 millimeter orifice. So, you know, this is clearly designed for a 20 amp dedicated circuit. Even a 20 amp circuit with other stuff running isn't going to work. You're going to need it to be dedicated. So yeah, the machine works quite well. Yeah, I mean, the output is the best of spec, best in the class of all the different pressure washers. You know, I think you know, the extra heft and weight and the fact that it needs a 20 amp circuit would make sense. I don't think we need the hot version. I have to look. I think there's a 630 TSS, which I believe is rated to 140, 150 degrees. So if that can save us a few bucks, then you know, this might make sense in the mid-tier range, maybe even over the Comet. So I don't know. We'll have to see. I might have to make a call to AR and see after all the trash I've been talking about their plastic stuff, if they'll let me sell this thing. But I might have to make a call and see if this is viable, because the performance is really good. I know lots of people have these, and you know, long-term testing, I don't foresee being a huge problem. My guess is it has a 1-year warranty, and it's rebuildable. You know, so it looks like you could change out seals and things like that. You could shorten the power cord. So you know, definitely looks like a viable option here. Not as simple to deal with as like a Comet. Just comes as one big package where you mount it to the wall, it has a hose and everything. But it does come with a hose that you're probably going to want to punt. But you could, out of the box, use this and hook up a foam cannon to it, you know, without having to buy all this other fancy equipment. But I think, you know, the combo would be to do a Cobra Jet hose, maybe even like a standalone Cox hose reel, like a little portable version, which I need to get in my store. And having, you know, a Mosmatic gun. And then I think the way to go is a 5.0 nozzle, gets us right just shy of 1,000 PSI, got us 2.32 gallons a minute. So we were to increase the GPM output by opening up the orifice size and decreasing the pressure a little bit. You saw we got great foaming. So yeah, not too shabby. Not too shabby in the test. This one wins. So anyway, thanks for watching this one. I'll continue to compile the data, and I'll eventually publish the data on obsessedgarage.com once I get it finished. I've got a bunch of Stanley pressure washers to test. There's quite a few others that I need to get in the garage to test out. And you know, hopefully this gives you a little bit of insight into when I get cranky, it's usually because something's junk. When I'm not, it's usually because something is worth testing and is interesting to me. So this machine here is interesting. Anyway, as a little bonus here, let's do a little GPM test on my big one, and we'll wrap up this video. A little bonus footage for you. Let's test the K165 STS, which I'll likely be replacing here this winter with the KWS 700. Let's just see what kind of flow we get out of the sucker. So I got a 6.0 nozzle. We get like 1,010 PSI with a 6.0 nozzle. This is rated at 2.8 GPM at 2,000 PSI. 3, 2, 1, go. But this sucker's like 85 dB, really loud. It doesn't have a pressure switch. The KWS 700, which is the current version, doesn't have the pretty stainless steel cover, but it does 3.3 gallons a minute. So it probably does like 3.5 gallons a minute, and it has a total stop. So it has the pressure switch that turns off when you release the trigger. That's main reason why I want it. And it's about $1,000 less, $1,200 less than the one that I have in here that they no longer make. 26.7 pounds minus 2.3 divided by 8.34. Yeah, 2.93 gallons a minute. So I gained a gallon a minute over spec. So, you know, I'm getting in that right at that 3 gallon per minute range. That's why I can run this at 975 PSI and get tons of work done. Because if you did the cleaning unit calculation, it's really strong. So anyway, interesting stat. Thought everybody's been waiting for me to test that thing, but you can see this stainless version is no longer available, but this runs for 30 seconds, which is annoying. So I'm probably gonna revamp my whole system, put some big DI tanks in here, and revamp my wash bay. I just talked to a painter. I'm gonna repaint this, change the lights, change the cabinets. So Wash Bay 2.0 is coming up here, and I'll be sure to share that as we go through the process. Anyway, thanks for watching this video. As always, stay tuned for more crazy. I got more coming. Thanks for watching.